Hello, ladies and gentlemen, and welcome back. This is Algebra 1, Section 1.5 for Prospect Charter School's Algebra 1 class. Today we're going to be talking about roots and real numbers. By roots, we're not talking about the roots of a tree or trying to find the root of a problem, pun intended. Indeed, we are looking at the mathematical root. Now, roots are really complicated. So what we're going to do is we're going to focus exclusively on the square root. Now the square root is what undoes an exponent, mainly the exponent called the square. So square roots undo exponents. In essence, they ask the question, what number times itself gives me this number? In other words, what number multiplied by itself gets us to where we started? So for an example, let's take a look at 16. So if we were to find the square root of 16, we would say, okay, what number times itself would give me 16? And we'd probably start with a number that would make sense. 16 is an even number, so more than likely it's going to be two even numbers multiplied to get us 16. So let's start with the smallest number that's even, and that would be 2. And let's look at 2 times 2. 2 times 2 would give us 4. 4 is not 16. So it doesn't work. That's not the right one. This is wrong. 2 times 2 doesn't work. So the square root of 16 is not 2. All right, well, if it's not 2, 3 times 3 is, of course, going to be an odd number. So let's try 4 times 4. And 4 times 4 gives us 16. And that's a winner. So we would say, in words, the square root of 16 is 4. That's a lot of writing. In math, we like to simplify things. We don't like to do a lot of writing because some of us are dyslexic and we don't like to write because words decide to bounce around on us. So mathematicians came up with a symbol to represent the square root. And the symbol was so awesome they called it radical. Yes, indeed, this is the radical symbol. And by radical, I do not mean the kind of people that fly airplanes into buildings. Those kind of people I don't like very much. I think that flying airplanes into buildings is bad practice. I mean, you don't even learn how to land that way, and it's just bad. It's a waste of everything. So don't do it. Don't fly airplanes into buildings. It's bad. Very bad. Not good. Instead, we have the mathematical radical, which looks like a house. Indeed, if you lived inside, you would be kind of happy until you realize that there's no wall here. And then, wind would get in, and then dogs and cats, and then everything would be awful. So I guess it's not that good of a house. Oh well. So the radical means that we're going to, tells us that we're going to be taking the square root of whatever's on the inside. Inside of the radical is a number. That number has a special name. This is called the radicand. Radicand. And the way you can think of it is that if you take something and you can it, it goes inside of the thing. So like if this was a canned person, then he would be inside of the can. So a radicand cans it in the radical. So that's an easy way to remember it. Alright, so we have the radicand, which is what we're trying to find the square root of, the radical that tells us that we're taking the square root, and then we take the square root. As we saw before, the square root of 16 is 4, so we would say this is equal to 4, box our answer, and call it a day. Or would we? You see, radicals are kind of weird. Sometimes radicals are good, and positive and happy, and sometimes radicals are bad and not happy and not good. So we're going to look at a few special cases. We're going to look again at 16. If we are looking for the square root of 16, and we said, oh, that's 4, we've already found that, we would be partially correct. There are other things that multiply by themselves to get to 16. In our previous lesson, we learned that a positive times a negative gives us a negative. We learned that a negative times a positive gives us a negative. We learned that a positive times a positive gives us a positive. And most importantly, and most weirdly, a negative times a negative is a positive. So when we were looking at our numbers before, did we try any numbers that might have been negative? And the answer to that question is no, we were only looking at positive numbers. In fact, we were only looking at integers. In fact, we were only looking at whole numbers. That's like really, really restrictive on the number of numbers that we're looking at. So what we want to try is what happens if we try a negative 4. So if we're looking at the square root of 16, could that be equal to a negative 4 times a negative 4? A negative times a negative is a positive. 4 times 4 is 16. So does that mean that negative 4 is also a square root of 16? The answer to that question is, of course it does! Square root says anything times itself that gives us to that number will be the square root. We found 2 of them. So we have a new set of special symbols and concepts that we need to go over. The first one is called the principal root. This is not the principal like ours, Mr. Tim Dexter, who is awesome. We are talking about the principal root of the problem, mathematically speaking. The principal root is the positive root of the number. The positive root of the radicand. To get really math and easy. So if we're looking for the principal root, we're only going to have one, and that's going to be the positive root. So the way we write mathematically which one's the principal root is we say, okay, well, we're looking at the square root of 9. Because there's no special symbol over here, we are going to assume that it's looking for the principal root and just say 3. So we got our base covered there. But what about all the other roots? I mean, we already showed that we can have more than one root. Well, if we want both roots, we use this special symbol, if I can draw it correctly. A little positive or negative in front of our radical. When we do that, it tells us we want the positive and the negative root of it. So what's the positive root of 9? Well, that would be 3. And what is the negative square root of 9? Well, that would be negative 3. Then we have the third case where we want only the negative root, in which case, guess what's going to be in front? That's right, a negative sign. If we're looking at the negative square root of 9, because we can always assume that the negative is really multiplication, and we're saying, oh, we're multiplying by negative 1, then we're saying negative 1 times the principal root of 9, which is negative 1 times 3, which is negative 3. So if we see that negative in front, we can always assume that it's multiplication. If we see the plus or minus, it says I want both roots, and if we see nothing, we are assuming that it means that they want the principal root of the answer. All right. So, would you like some more examples? Usually at this point you would say, yes, we want more examples. Okay, so let's look at some more examples. Let's look at the square root of 1/4. So we're asking ourselves, okay, what times itself gives us 1/4? Note, no positive or negative out here, so we're just looking at the principal root. That means we're only looking at the positive root. Well, to do this one, we can look at it in a variety of ways. The easiest way is to break it into 2 square roots. The square root of 1 divided by the square root of 4. When we do that, we can easily assume, or easily figure out what the square roots are. Square root of 1 is 1, and the square root of 4 is 2. So the square root of 1/4, which can be broken into the square root of 1 divided by the square root of 4, is equal to 1/2. Easy as pie? Yep, I thought so. Alright, let's take a look at some other square roots and see if we need them. And we do not. Okay, so far, all the numbers that we've been working with have been pretty simple. They have been giving us rational roots. But what happens when we don't have a rational root? For example, when Pythagoras was, of course, given this problem to work through, he said, there's got to be a fraction that works. Well, we know from our previous lesson about the families of numbers that this is what's called an irrational number. There is no fraction that can properly state what the square root of 2 is. In fact, we don't even know what the real square root of 2 value is, other than to say it's the square root of 2. We can calculate it out to the quadrillionth decimal place, but we still don't know the exact value. Because of that, we usually like leaving them in this format as the square root of 2, because then things cancel nice and easy. But if we don't, if they want to know a decimal value of it, then what we would have to do is we'd have to use our calculators. So I'm going to go ahead and see if my computer's calculator can handle this. So we go into here, and then we go to this place, and then we say, I want calculator. So I go, there it is. Hello, calculator. Okay. And did it pop up? Yes, it does. All right. So here's our calculator, and we want to find out what the square root of 2 is. So we would say, normally we go, oh yeah, square root of 2. But if you notice, our calculator didn't do that correctly, so we have to do it weirdly if we're working with a scientific calculation. We would put the number that we're looking for the square root of first, in this case 2, and then we would hit the square root button, which looks like a little check mark. Shazam. Notice how it says SQRT2. That is Mathanese for square root of 2. And so, when I go back to my project, I'm going to write down 1.414213562373095, right? No, we're not going to do that. What we are going to do is we're going to use our brains and say, okay, that's a ridiculously long decimal. This is a irrational number, so the decimal actually never ends, so I'm not going to write until my hand bleeds. I'm not that kind of a guy. Instead, what I'm going to do is I'm going to shorten it. Usually the best way to shorten it is to use the first 3 decimal places. I know that you've seen this before, such as with pi being 3.14. We don't go to the nth decimal place on pi. We just go to the second. So if I'm looking at the square root of 2, and I want to find its value, I would say it's approximately 1.41. And then I would be done. Unless it states otherwise, always just round to 2 decimal places. That's a really good assumption to use, unless you're in scientific notation or you're in a science class or you're in an upper division math class. Until otherwise stated, just go to 2 decimal places. You'll be fine, at least in my textbook. So what about the square root of 3? Well, to do the plus or minus the square root of 3, once again, I come up to my calculator, and I say, okay, well, let's clear it out. Clear. All right, so now it's perfectly clear. And again, I need the radicand, which is 3, and then I use my radical symbol to discover its square root, and I get 1.73. So the positive or negative square root of 3 would be the positive or negative 1.73? Yep, 1.73. So that's how we deal with the irrational numbers. Now there are cube roots, and there are a lot of other things, such as a terminating decimal or repeating decimal. We're not going to go over those because they are self-explanatory. A terminating decimal ends, terminate means end. A repeating decimal repeats. We already know about rational numbers. We already know about integers. We already know about all the numbers in the universe. because we're awesome. Alright, now it's time to go ahead and start on our homework. This is going to be Algebra 1, and we are looking at section 1.5, and we're going to be on page 35, and we're going to be looking at the following numbers. Now, more than likely, there's going to be a whole lot of numbers, but guess what? They're probably going to be really easy. You're probably going to be able to use your calculator for them if you so desire, especially the irrational ones. But try to figure out what the number would be without resorting to your calculator right away. Part of being a good mathematician is being able to do calculations without your calculator, because as we saw, it actually slows you down. When I had to look up the square root of 2, that took a lot longer than trying to find the square root of 9. So let's go ahead and try these. We're going to be looking at numbers 3 because it's cool, 9, 11, 17. Now these are cubed roots. I hope you can find those out on your own, because part of being a good mathematician is figuring things out. 21. And if you need more help with cubes, please feel free to ask for help in class. Let's see, 21, 25, super easy, 29, 33, 35, and then we need some word problems, so 49 and 51. Now this isn't nearly as many as last time, so you can, of course, assume that the difficulty will be higher than the last time. And it is. Some of these actually require some creative thought because I didn't cover it, and I didn't cover it on purpose because I want you to be able to learn on your own. The most important lesson that I can teach you is how to learn on your own. All right, thank you very much. Good luck and have fun.